This is Edexcel's GCSE Mathematics Practice Test Set 4, Paper 1F. Question 1. Simplify 3f, take away 2f, add f. Well, 3 take 2 is 1, add 1 is 2f's. Question 2a. Write down the value of the 6 of the number 26,780. Well, that is in the thousands column, so it is 6,000. You should always write it out in full, not using numbers. Part B, write the number 6,749 to the nearest 100. Well, to the nearest 100 would be this column, so we want it to be rounded off after here. It's a 4 straight after the 7, so it will stay as a 7, so that's 6,700. Part C, write 0.0763 correct of one significant figure. The most significant figure is the 7, so we want to round off after here. So the 6 after it means that the 7 will round up to an 8. So it'll be 0.08. Question 3. Here is part of a railway timetable. Work out how long the 10:13 train takes to go from New Street to Coventry. So this is a 10:13 train. We're going from New Street, which is the 10:13, down to Coventry, which is at 10:47. So if I want to set off at 10:13, to get to 10:47, if I add on 30 minutes, that will get me to 10:43, and then I'm 4 minutes away. So that would be 34 minutes. Harry is at Birmingham International and he needs to get to Tile Hill by 11 o'clock. What time is the latest train from Birmingham International that he can catch? So he's at Birmingham International, which is here, and he wants to get to Tile Hill by 11. So he could get that one. This one skips Tile Hill, so that arrow means that it skips Tile Hill, and that one gets there at 10:55. So he can catch this train here, and that leaves Birmingham International at 10:45. Question 4. Liz asked 20 people to name the flavour of chocolate they like the best, and there's her results. Complete the frequency table. Well, the tally bit needs to be filled in with the tally, so I'm going to tally the milk first. So milk is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 milks, and you do that in the same way for them all. So that the plain ones, when you tally them up, there are 4 of them. The coffee ones, there are 3 of them. The orange ones, there are 3 of them. And the white ones, there are 2 of them. Make sure you cross them off as you go, and you make sure you keep that accurate tally. On the grid, draw a suitable chart or diagram to show Liz's results. Well, you've got a lot of squares here, so you could use quite big bars, but I just prefer to keep it simple. And the highest number in the frequency is 8. So the frequency goes up the side, and I'm just going to go up in 1s just to keep it simple. I could go up in 2s, but it's best that we just don't make mistakes. There is space to go 1, 2, 3, all the way up, and because there are 16 squares, but I'm just going to go up like that to be safe. Along the bottom, when you're drawing a bar chart, we put the flavour along here. All the bars must be the same width, and there must be a gap between each one. So I'm going to use 1 square as a gap, and then I'm going to do each bar as 2 squares. So this would be the plane. I'm going to leave a gap, and then 2 squares for the next one, which would be milk. I'm going to leave a gap, and then 2 squares for the next one, which will be coffee. Leave a gap, and then 2 squares for the next one, which would be orange. And then leave a gap and 2 squares for the next one, which would be white. Again, you could have probably used 3 squares there, but I'm just going to play it safe. I know it can fit on the squared paper. So the plain one needs to go up to 4. You don't need to spend ages colouring these in, just shade them in so it's nice and easy to see. The milk one needs to go up to 8. The coffee one needs to go up to 3. The orange one up to 3, and the white one's up to 2. Okay, so bar chart's the best way of displaying that data. Nice and simple, space between each bar, and each bar needs to be the same width. Make sure you label your axes, because there is a mark for that. So the flavour on the bottom, frequency up the side. Question 5. Susan and Joe are going on holiday. They could take 2 cases onto the plane free of charge if it's under 40 kilograms. Susan's is 22.8 kilograms and Joe's is 19.5. Can they take them? So we need to add these together. So 22.8 plus 19.5. There'll be quite a lot of using proper column methods in this paper, so you need to make sure you're really good at that. So first of all, I'm going to put my decimal place in. 8 add 5 is 13, so 3 down, carry the 1. 9 add 2 is 11, add your 1 is 12, so 2 down, carry 1. And then 2 add 1 is 3, add 1 is 4, so it's 42.3 kilograms. And it asks, can they take it on? So you must write, no they can't, because it's more than 40. So no they can't is fine. Susan and Joe want to be at the airport for 2:30. It will take 1 hour and 20 minutes to drive to the airport and 30 minutes to get parked. What's the latest time they can leave home? So again, when it comes to time, I always use a number line. So they need to get there by 14:30, by 2:30. So if I take 1 hour and 20 minutes off that, so minus 1 hour and 20 minutes, an hour would get me down to 1:30, and the 20 minutes would get me down to 1:10, so 13:10. I then need to take off another 30 minutes. So don't forget there's only 60 minutes in an hour. So take 30 minutes off that. 10 minutes will get me down to 1 o'clock and another 20 minutes down to 12:40. So they must leave by 12:40 at the latest. Now you'll notice I've not been putting AM or PM, and that's because all of these times are the 24-hour clock. So 12:40 means 12:40 in the afternoon. So you don't need an AM or PM. Question 6. Sarah wants to buy some fruit. She wants to buy 3 oranges at 30 pence each and half a kilograms of apples at £1.20 a kilogram. She only has 1 50 pence coin and 6 20 pence coins. She pays for the fruit. How much change does she have left? So first of all, let's work out how much these cost. So 3 lots of 30p equals 90p. And we've only got half a kilogram, and it's £1.20 for a full kilogram. So we need to half £1.20. So a half of £1.20 is 60p. So if we add those two together, you get 150p or £1.50. We've then got a 50p coin and 6 lots of 20p. Now 6 lots of 20p is 120p or £1.20. So we add those together, we've got £1.70. So she's got £1.70. She spends £1.50 on the fruit. That means she's got 20 pence change. Or you can just write that as 20 pence if you want. Question 7. Tanaka says, when you multiply an odd number and an even number together, you will always get an odd number. Show that she's wrong. So basically, you just need to choose an odd number. So I'm going to go for 3. And an even number, I'm going to go for 2. Just keep it nice and low. You don't need to go to any big numbers. 2 times 3 is 6. So that's an odd times an even equals an even number, because 6 is even. So that means she's wrong. So we've shown that she's wrong there. Question 8. Write down the mathematical name for the type of angle marked X. Well, this is more than 180 degrees. 180 degrees is a straight line along here. So it's more than 180, so it must be a reflex angle. Part B, work out the size of the angle marked Y. Be careful, these are not drawn to scale, so a lot of people start to measure here, but what you need to know here is that angles on a straight line add up to 180. So we need to do 180 take away 126. Now to do that, 0 take 6 we can't do, so that becomes a 7 and that becomes 10. 10 take 6 is 4, 7 take 2 is 5, 1 take 1 is 0, so 54 degrees. A lot of proper column methods in this paper. Give a mathematical reason. This is where you've got to be really careful. You've got to say it in full sentences. So angles on a straight line add up to 180 degrees. Now a lot of people don't use the words add up to, they put equal to. They are not equal to 180, because equal would mean that each one is 180 each, and they're not. They add up to 180. So make sure you use the word angles, straight line, add up to, and 180. Really, really important. Part C, complete each statement correctly. The size of each angle of a rectangle is, well, a rectangle is a 4-sided shape like that, and they are all 90 degrees. So 90. The size of each angle in an equilateral triangle. An equilateral triangle is one where all angles are the same and all sides are the same. So because angles in a triangle up to 180, we divide that by 3, which would be 60 degrees each. Question 9. Find two factors of 36 with a difference of 5. Well, first of all, I'm going to find all the factors of 36. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 times 6. Now a difference of 5 means that when you take them away from each other you get 5. So we could have had 4 and 9, would be a perfectly good answer, or we could have had 1 and 6 as well, they would have been fine as well. The lowest common multiple of 3 numbers is 30. 2 of the numbers are 2 and 5, what could the third number be? Well, if they all go into 30, we need to find the factors of 30. So we've got 1 and 30, 2 and 15, 3 and 10, 5 and 6. Now, from that, we've already got 5 and 2 being used. It could be any of those other numbers, apart from 1. Because if 1 was there, then we would be able to have a lowest common multiple of 10 with that, wouldn't we? Because 2 and 5 go into 10, and so does 1. So, any of those other numbers we find, I'm going to choose 3, the smallest one that we can have. So the smallest common multiple of 2, lowest common multiple of 2, 3 and 5 would be 30. Question 10. Debbie, Salma and Wendy did a maths test. The total for the test was 40 marks. Debbie got 16 out of 40. Salma got 35% and Wendy got 3/8 of the marks. Who got the highest mark? Well, Debbie, we already know, has got 16 marks. We just need to work out Salma's, and also we need to work out Wendy's. See how many marks they've got. So to find 35%, you would do 10%, 10%, 10%, and 5%. So 10% we divide by 10, so 10% is 4. So we want 3 lots of 10%, so 3 lots of 4, and 5% is half of 10%, so that's 2. 4 and 4 and 4 and 2 is 14 marks, so she only got 14 marks. Wendy got 3/8, so 3/8 of 40. To do that, we do 40 divided by 8, so we split it into 8 equal pieces, and then times by 3. So 40 divided by 8 is 5, and times by 3 is 15. So Wendy got 15 marks. Now it does say who got the highest mark, so we have to state who got the highest mark. So Debbie got the highest mark. You must always write a sentence when it asks you a question. Question 11. Write down the coordinates of the point C. So we always go along the corridor and up the drive, so that is 7, 3. Find the coordinates of D so that A, B, C, D is a parallelogram. So we've got A, B, C and D, alright? So if we look over here, it must be just here because that goes along 2, up 2, so this must go along 2, up 2. So D must be just here, and that is at -1, 5. Now there are different answers for that one actually. We could have had a point down at 3, 1 because just there it actually makes a rectangle in there, and you could have also gone off the page over here and made a parallelogram over this way, but we'll just stick with -1, 5. It says E is another point on the grid. The midpoint of AE is 2, 6. So from A to E, the midpoint would be at 2, 6. So the midpoint is just there. So I've gone along 1 and up 3 to get to there, to the midpoint. So to get to the end of it, I must go along 1 and up 3 again. So the end of that line must be at 3, 9. Question 12. There are 11 counters in a bag, 6 are green, 5 are red. Some more red counters are put into the bag, and then a red counter is taken at random. The probability is 3/5. How many red counters are there in the bag now? So, originally there were 5 11ths in there, so 5 out of 11, and now there are 3/5. Now 3/5 means you've got 3 out of 5, but there were already more than 5, so we need to do equivalent fractions until we've got a number that's more than 11, because we've added extra in there. So if we double both of those, it could be 6 out of 10, but we've still not got enough there because we've still only got 10 counters in the bag. So we times it by 3, we could have had 9 out of 15. Now if you look at 9 out of 15, that is adding 4 to the top and adding 4 to the bottom. So you've added 4 to the total in the bag and you've added 4 red ones. So that is where it must have worked. So we must have added 4 red counters. Question 13. Here is a sequence of patterns made from sticks. Complete the table for the number of sticks. So we're going up in 1, 2, 3, 4, 5. So always check that that is a number 5 and they've not jumped up to like the number 10 or something. So it's going up in 5s. So we just need to add 5 onto that, which will give us 27. It says find the number of patterns in pattern number 8. So we can just go 6, 7, 8. Just keep on adding 5. So that'll be 32, 37, 42. If it was much more than 8, I would use the nth term rule, but it's asking for the nth term rule next anyway. It says find an expression in terms of n for the number of sticks in pattern number n. That just means find the nth term rule. So it's going up in 5s, so it's linked to the 5 times table, so it's 5n. The 5 times table starts at 5, and ours starts at 7. So basically this is just the 5 times tables, but plus 2. Ali has 60 sticks. She wants to make as many sticks as possible to make a pattern number. What is the largest pattern number she can make? So to do this, if we do 5n plus 2 equals 60, to try and solve that, take 2 off both sides, we get 5n equals 58, and then divide by 5, we get 11 remainder 3. So she can make 11 full patterns and she'd have 3 sticks left over. So the most she can make is 11. Question 14. On the grid, draw the graph of x plus y equals 4 from -2 to 5. This bit usually confuses people because they think they have to do a full table from -2 to 5. It just means that your line has to carry on past -2 and past 5. So all this means is that we want 2 numbers that add together to give 4. So we could do 0 add 4, we can do 1 add 3, we could do 2 add 2, 3 add 1, etc. Okay, and you can see they're in a nice straight line and they go through the corner of each of those. Like that, and we need to go straight past -2, so I've gone past -2 and past 5. Now I could have done a table and that would have been fine as well. I could have rearranged it and taken the x on the other side, that would become a -x plus 4. And if you did that, then using y equals mx plus c, it's got a gradient -1 and a y-intercept of 4. So we're starting at 4 and going down 1 each time. It'll give you the same answer. The best way to think about it is 2 numbers that add up to give 4. Question 15. Tom is going to buy 25 plants to make a hedge. Here is information about the cost of buying the plants. So Kirsty's is £2.39 each, and Hedge World is a pack of 25, is £52.50 plus 20% VAT. He wants to buy them as cheaply as possible. Which one should he use? So, again, we're using proper column methods here. You need to get really good at these. So £2.39 times 25. So, we're going to times by 5 first. So 5 times 9 is 45. So 5 in the column and then carry the 4. 5 times 3 is 15, add your 4 is 19, so 9 down, carry your 1. Don't forget your decimal point. And 5 times 2 is 10, add your 1 is 11. So 1195. We're now going to times by this 2, which is actually a 20. So if we put a 0 down first and then multiply by 2, that'll be the same thing. So 2 times 9 is 18, so 8 down, carry your 1. Don't forget your decimal place. 2 times 3 is 6, add your 1 is 7. And 2 times 2 is 4, so 4780. If we add those together now, 5 add 0 is 5, 9 add 8 is 17, so 7 down, carry 1. 1, 7 and 1 is 9, and 1 add 4 is 5, so it's £59.75. Over at Hedge World, it's £52.50. And to add 20% VAT to that, we need to find 10% by dividing by 10. Now divide that by 10, you get £5.25, and we want another 10% on top of that, because we want 20% altogether. So another £5.25, and if we add those together again, we've got 0, 5 and 5 is 10, so 0 down, carry 1. Be really careful you don't think that's a 6 afterwards, it's a 0, 10. 5, 2, 2 and 1 again is 10, so 0 down, carry 1, decimal place. 2, 5 and 5 is 12, add your 1 is 13, and 5 and 1 is 6, so it's £63 from Hedge World. So we've now got to actually state, you can't just think it's obvious, you've got to state that Kirsty's plants is cheapest. You must write that sentence. The last mark is for that sentence. Question 16. The diagram shows the cross-section of a solid prism. So it's a cross-section of a solid prism. That means that this is actually a 3D shape going back here. So a lot of people, when I marked this question, just left it as a 2D shape. So it's actually a 3D shape, and it goes back 2 meters. Now the really important thing is that all these are in centimeters, and this is in meters. So you've got to remember that 2 meters is 200 centimeters, and that's your first mark there. So to find, it says the prism is made from metal. The density of the metal is 8 grams per centimetre cubed. So we want to work out how many centimetres cubed, or the volume of this shape. And then every centimetre cubed will weigh 8 grams. So we need to multiply the volume by 8. To do the volume of a prism, we find the area of the cross-section. So the cross-sectional area is the front. So 2 times 7 is 14 centimetres squared for this rectangle. And this rectangle here, the full distance is 7, and that distance is 2. So this distance here must be 5. So 5 times 2 equals 10 centimetres squared. So the cross-sectional area is 14 plus 10, which is 24 centimetres squared. To find the volume, you then multiply the cross-sectional area by how far back it goes. So 200 centimetres, not 2. So 24 times 200 is 4,800 centimetres cubed. And it says to work out the mass of it. Now the mass is just basically the weight. So 8 grams per centimetre cubed. So we've got 4,800 centimetres cubed at 8 grams each. We need to do 8 times 4,800. Now the best way to do that is again with a normal column method. So 8 times 0 is 0. 8 times 0 is 0. 8 times 8 is 64. So 6 down and do 4. And 8 times 4 is 32. Add 6 is 38. So it's 38,400 grams. Now it doesn't ask for it in grams or kilograms, so that's a perfectly fine answer. If you did put it into kilograms, it would be 38.4, but there's no mark for that. Question 17. There are 50 counters in a bag. The counters are either blue, yellow, black or white. A counter is taken at random, and the table shows the probability that it's blue, black or white. Work out the number of yellow counters in the bag. Well, first of all, if these are all the counters, these must add up to a whole one. So if we add these up, 0.4, add 0.3, add 0.16. Again, using the column method, this would be 6. 4 add 3, 7 add 1 is 8. So 0.86. 1 take away 0.86. This is in the hundreds column, so these need to add up to 100, so it's 0.14. And then we need to do 0.14 times 50, because basically 14% of these, of the 50 counters, are yellows. So 0.14 times 50, the best way to do that is to times by 10 first, so you get 1.4, and you still have to multiply by 5. And then to do 1.4 times 5, again, I would use the column method. 5 times 4 is 20, so the 0 down, carry a 2. And then 5 times 1 is 5, added 2 is 7. So 7 is your answer. Question 18. Work out an estimate for the value of 6.8 times 191 divided by 0.051. Well, we always round to one significant figure. So 6.8 would round to 7, 191 would round to 200, and 0.051 would round to 0.05. 7 times 200 is 1,400, and we want to divide that by 0.05. Now, divided by decimals is always difficult, so what I would suggest is this is basically a fraction, so we can do equivalent fractions here. If we times the bottom by 100 to make it 5, if we times the top by 100, it won't change our answer. So times the top by 100, add 2 zeros, times the bottom by 100. That is the same sum as that. So to do that, we can just use then the bus shelter method. 1, 2, 3, 4 zeros. How many 5s into 1? None. Carry a 1. How many 5s into 14 is 2, carry a 4. How many 5s into 40 is 8. Into 0 is 0, 0 and 0. So it's 28,000. Question 19. The normal price of a television is reduced by 30%. The sale price is £350. What was the normal price? So we don't know what the normal price was. Now this is a non-calculator paper. So £350 is actually 100% minus 30%, so that's 70% of the original price. So we know that 70% of the original price is £350. We want 100% to get back to the original price. So the best way to do that is to work out what 10% is by dividing by 7. And then, once we've got that, times by 10 to get back up to 100%. So 350 divided by 7, 35 divided by 7 is 5, so that would be 50. And then times by 10, that gets us up to 500. So the answer would be £500. Question 20. A, B, C, D, E and A, F, G, C, H are regular pentagons. So regular means all sides and angles are the same. Pentagons means it's got 5 sides. So these are overlapped. So this is one of the pentagons, and the other one is the black one. It says work out the size of angle EAH. So E to A to H is this angle just here. So that's the angle that we're after getting. Now, the best thing to know about regular polygons is that the external angles is always 360 divided by the number of sides. So 360 divided by 5 is 72. So that means, if I draw a line along here, that angle there is 72. And because that's a straight line, I know that this angle here must add up to, make it add up to 180. So this would be 180 degrees. So 72 take away 180, take off 180 is 108 degrees. This angle here will also be 180 degrees because these are regular, because they're all the same. Now, this in the middle is just a 4-sided shape. Now, 4-sided shapes add up to 360. So if we do 360 minus this 2 lots of 108, 2 lots of 108 is 216. So 360 minus 216 is 144. Now, that's for both of these angles here. So 144 divided by 2 equals 72. So this angle here must be 72, and this angle here must be 72. Now, the reason why I've worked those out is because this full angle here is just an internal angle of that pentagon, which we've already worked out is 108. So to work out this angle, if we know that that's 72 and this is 108, we could just do 108 minus 72, which gives us 36 degrees as our final answer. So the angle that we're after must be 36 degrees. Question 21. It says, Harry travels from Appleton to Brockley at an average speed of 50 miles an hour. He then travels from Brockley to Cantham at an average speed of 70 miles an hour. It takes a total of 5 hours to get from Appleton to Cantham. The distance from Brockley to Cantham is 210 miles. Calculate Harry's average speed for the total distance. Now, that's a real mouthful, so you need to start drawing a picture for this one. So, 3 places. So, Appleby to Brockley to Cantham. So, we're just going to, it doesn't matter that it's a straight road, we'll just presume that it's straight, because the distances don't matter whether it's straight or not. The information that we've got is from A to B, we travel that at 50 miles per hour. And then from B to C, we travel that at 70 miles per hour. It says it took a total of 5 hours, and the distance from Brockley to Cantham is 210 miles. Now, when I marked this exam question, a lot of people just averaged out 50 and 70 and said the average would be 60. But that would be presuming that the distance between A and B is the same as between B and C. And we don't know that, so we've got to figure that out first, okay? So, the first step is to figure out how long it takes to get from B to C. Now, if you do 210 miles at 70 miles per hour, that means 70 miles in every hour. So 70, 140, 210, that would take 3 hours. So this bit must be 3 hours. And if it's 5 hours in total, that means that this bit must be 2 hours. If we know that it takes 2 hours to get from A to B at 50 miles an hour, then 2 hours at 50 miles per hour means that you do 50 miles in every 1 hour. So in 2 hours, that would be 100 miles. So we know that this distance here is 100 miles. So the total distance then is that 100 miles that we just worked out, plus the 210 that we were told, is 310 miles. And it took him 5 hours. So speed equals distance over time, so we can rearrange that to working out the average speed. So speed equals distance over time, which is 310, divided by the total time, which is 5 hours. And the best way to do that, again, is just do bush shelter method. So how many 5s go to 3 is none, carry a 3. How many 5s into 21 is 4. Sorry, that's a 31, isn't it? Sorry. How many 5s into 31 is 6, sorry. Remainder 1. And how many 5s into 10 is 2. So that would be 62 miles per hour. Just be really careful about, like I just did then, thinking that that was a 2 when I've written it down wrong. Time and time again, I see people writing numbers down, especially zeros, where zeros look like a 6, and then they forget what they've written and actually add 6. Alright? Be really, really careful. Make sure that all your numbers look exactly what they're meant to be.